So thank you, Sergio. I'm going to talk about how ALTA sees product quality, product assurance in new space. This is rather an evolving sector, and we think that there's a lot to do concerning quality. Okay. So first of all, I don't know if you know ALTA Technology. We are a quality-based company. We are in fact we belong to the TÜV Nord group, which is a German, very old German quality-oriented company, and we are its aerospace unit. So ALTA is a Spanish company with 34 years of history. We have 4 sites: one in Seville, one in Madrid, in Dos Cantos, one in Toulouse, and one near Edinburgh. We are 275 people, and we have more than 6,000 meters of laboratories. We have worked in most of the big European Space Agency missions, such as the ones you can see here: Rosetta, Solar Orbiter, JUICE, Plato, and we work every day with most of the big actors of the space: Airbus, OHB, Thales, and what do we do in space? We work at a component level, which is the upper services that we provide, for example, part engineering, component engineering, testing of components, procurement of components, and also at a equipment level. So we test equipment, we develop equipment also, we certificate them, we do CE marking for those equipments which are not from space but from industry, and we test small sats. Okay. So as I am the first speaker, I am allowed to do a short introduction to new space. So what's in a word? What's new space? New space is basically democratization of the access to space. This is boosted by new services. Everyone who wants to be connected everywhere. New applications, for example, Earth observation, as Sergio was saying. With a short revisit time for applications such as safety, security, fleet follow-up, infrastructure follow-up. New space is also characterized by new architectures, cheaper launchers. We have very big launchers. We have very small launchers. We have launchers which are doing things like Starship, so they are the launcher and the how to say, the navette in one single ship. We have a new standard of satellites, which is the CubeSat and all its evolutions. And we have huge constellations of satellites going around the world and communicating amongst each other. We have new industrial organizations with limited budgets, with accelerated development times. We have the key for us, which is adoption of risk, acceptation of risk. And we have also new technologies, deep technologies, finding its place in space, such as artificial intelligence, quantum communications, blockchain, or direct optical communications between satellites. So if we take a look at the numbers, the hard numbers of new space, we see that this graph is the success rate of the new space missions, just in the NANOSAT range. So this would be below 50 kilo. We see that the success rate has increased a lot in the past years, but we are still in around 75% of success rate. So we think that there's a first hint that I mean, no industry would allow 25% of failure rate whatsoever. That means that one car out of 4 you cannot sell it. One mobile telephone out of 4 you cannot sell it. So this means that the industry has to do something before getting to be commercially profitable. Also, if we look at the launches of nanosats, we see that despite the expectations are overall booming, the hard facts are that for the past 3 years, the launches have been decreasing steadily, and this is another hint that there might be something going on in the industry in terms of, well, maybe we think that there can be problems with the quality, or that not anything can be launched. So we think that these are again another idea pointing to our idea that quality has to be improved in new space. How do we see the future? We think that between traditional space where reliability is full reliability is a must. All components are red hat +1. All components and equipment are tested. And the industrial world, where you can use COTS components, there is no testing at component level. For example, you self-certificate your equipment. There is a lot of room in the gray zone to do things differently. So we think that finally space and new space and traditional space will converge somewhere. And we're trying to fill that gap. We think that also there will be a kind of rebound effect if we compare what happened with the mobile telephones. In the 90s, telephones were big. In the early 2000s, they were very, very small, and now they're becoming big again. We think that there's going to happen something similar in the space sector. Okay, so we have demonstrated that we can launch satellites that fit in your pocket. But these satellites might not be commercially profitable, and the room is too small for real industrial applications. So somehow the nanosat standard will get to somewhere between the 6 and 12 units. Also, new space is still space. We still have launches. We still have daily day and night cycles. We have shock. We have cleanliness issues. So, but we need to handle all this in conjunction with limited budgets and, even more important, short development times. So we get to the idea very clearly of risk management. We need to not to avoid risk, not to accept all risk, but to manage risks, as in every other industry, by the way. So what can you do to manage risk? You can work at component level. You can choose your components from a wide range of grades, of classes. You can take advantage of course, of flight heritage. You can you can talk to the manufacturers and develop your own components. You can test. You can check obsolescence control, because this is a huge problem in COTS components. We have developed a tool called Do It, where we have more than 20 million reference of electronic components, and where we can do things such as what we call crowd testing, which is a mutualization of testing of space components. And there's a whole lot of information about the components there, about obsolescence, heritage, test reports. And I encourage you to take a look at this site. Also, you can do we can help with component testing in a classical way. There's packaging packaging or repackaging is a very versatile way of adapting COTS components to space. So this is something that we can also do. We can do package standard components into what the particular client needs, and also testing at equipment level. ESA has recently recognized that new space opens the room for different ways of testing at equipment level, and they have issued these ITT, which where we have participated. We don't know the result yet, but this confirms our ideas that testing differently is going to be certainly important. We can help out with all sorts of equipment level testing. And something that has been very important for us in the past year, with the pandemic situation, is remote testing. We have developed a remote testing tool called Virtual Lab that helps clients testing without being physically in our lab. So you have in real time all the information about the test, and you don't need to wait for the results to be processed because you have them right away. Also, we have the idea that, as in any other mass industry, testing is not done in every single element, in every single serial unit, but we think that there should be room for certification of constellations. So, for example, as you would do in any other industry, if you fully test and certificate the first model, and then you have a yearly auditing process that ensures that your manufacturing, your testing, your designs are agreeing to your quality system, your products will be also certified. We are approaching constellation manufacturers and constellation owners to present them this scheme, and we think that there might be quite a lot of room for it in the future. So another thing that we are very interested about is the space sustainability. Finally, TÜV is a qualities company, and sustainability is a major part of it. And people are launching a lot of satellites up there, and many of them have very limited capabilities in terms of maneuvering, of situational awareness. And this is going to be a real concern for all the space industry in the following years. So we are trying to get into a space sustainability quality certificate that would certificate that a certain mission is sustainable, and that, for example, its chances of collision are minimal. That if there's a risk for collision, you can maneuver. What's going to happen with the satellite at the end of time, and also how the satellite has been built according to sustainability standards. So in conclusion, new space is here to remain. It's basically democratization of the access to space. New space is also enabling new technologies to go to space, deep technologies. Quality is still a major concern for new space, and a risk management approach has to be adopted for new space missions to be commercially profitable. And these new space, risk management tools need to be assimilated by new space actors. This is everything. Thank you very much. If you have any question.
Okay, thank you very much, Eladio. Thank you. For those of you who have any question for Eladio, you can write it in the chat. I have one question for you, Eladio. Alter Technology is working in the aerospace sector for a long time. Then this emergence of the new space, in a few words, how would you say that it has changed the way you work at Alter Technology, your processes, the way the approach that you make to any project?
It's mainly faster, cheaper, and in a much more agile way. So, for example, I mean, lead times for traditional space are, I mean, you know what's going to happen in the next months, and this doesn't happen in new space. For example, you know when to expect the tests to come, or I mean, it's slower, and in new space everything has to be much faster. I mean, it's just like any other traditional industry. That would be transportation or communications or.
Okay, but are you dedicating the same labs, the same people that you used in the past projects, in the other projects that you had in the old space?
Yes, because the requirements, the new space requirements are basically low Earth orbit requirements. So you still have vibration, you still have shock, you still have TVAC, and everything is much the same. But you need to do it faster and cheaper if you can.
Okay, thank you very much, Eladio. I don't know if anyone has any other question. No.
I put a couple of questions on the chat.
Yeah.
Yeah, I don't know. Maybe you did not read. Yeah. My comment was that since almost the beginning of space, let's say flight, there's been a tendency to qualify a cost component in the most fast, effective way. So this is, in this sense, what we are trying to do now, for this NANOSAT constellation, new space, is something that has been already done. I remember with SILEX, 1985, the telecom experiment, which was very successful. Now the lasers, which were used for the link, were just taken from the market, and they were screened and tested. What I want to say, this is a procedure which is already done. My concern is this: if we want to establish an effective way of making cheaper, faster, to ensure qualification, and the qualification where the major cost is going. Qualification is one thing that I think the new space has to take into account, because you still have to fly, as Eladio said. And the other thing is tracing. Essentially, you will be able to have the processes to be traceable, in order that what you fly today, if you want to fly, in a couple of years' time, you don't have to start all over again. So I think to the overall cost, one has to consider all these elements. So it's very nice, this new space is very nice, but in terms of cost, we have to be very careful, because not always the ball is round here. Do you have any comment, Eladio?
Yes, this is what I was saying about obsolescence. If you're building a constellation and you're launching satellites in a single constellation for years, you have to be sure that you have replacements for every single component that you. I mean, it doesn't have to be the same one, but it has to have the same performance. So that's what I was saying about obsolescence, for example. So this is a key for us.
Yeah, exactly. The cost goes a lot into it. We have seen I've seen out also, with the ALBA, the window lidar, which the laser dot were bought many years before the launch. And the process, essentially, all this laser dot is completely lost. All tracing is lost. So it has been 10, 15 years for launch, as you pointed out. So I think this we have to be very, very, very careful about this. But
Yeah.
I appreciate your talk very much, Eladio, and I think you're touching critical points, which I appreciate Altair is taking the lead into this.
Thank you very much.
Thank you very much, Enrico, for your contribution. And
how do I stop sharing?
Okay, thank you. We have another quick question from Jesus Aibar from LIDAX. He says, Eladio, what are the main or the major reasons associated to nanosat mortality? For instance, the space radiation on electronic components or the launch loads. Which are the main reasons?
Yeah, well, I'm not a specialist on this, but I would say that many of the missions are demonstrator missions. So there are, of course, a lot of failure rate is on the launch, on launch problems, and a lot of them also, I would say, it's because they are missions which are not. They are demonstrating missions, and they are not supposed to last very long. I would say these are the two facts. Yeah.
Okay, thank you very much, Eladio.